So, hello everyone, welcome to the YouTube channel. Hope you are doing well. So, as you know, we have started the particular channel on the subject that is software engineering. Okay, so welcome you on that again. Yes, so we have covered lots of thing in the software engineering, software development life cycle. So we are not going into the full recap, but let me quick recap on the previous video. Yes, so dividing the software development phases into the communication or planning communication, or we can say the requirement analysis. Then we have the planning, then we have the modeling, then we have the coding, or we can say the coding plus testing, and then we have the maintenance. Okay, so in the so we have seen the communication chapter. We have seen the separate chapter on the modeling, that is the software designing, architecture design, user interface design, component level design, object oriented design. In the object oriented design, we have seen the different diagrams in the previous video: use case diagram, sequence diagram, state diagram, class diagram. So this was nothing but the object oriented design, that is exactly the modeling. Yes, so in the previous video we have discussed about the software designing and the implementation. So in the software designing, we have seen the object oriented design, right? In that we have seen the class design. So we were defining software designing is a creative activity in which you will be putting all your requirements into your paper in the form of class diagrams, in the form of use case diagram, in the form of state diagram, sequence diagram, and so on. While in the case of implementation is nothing but converting your modeling into the executable software, right? So we have seen the implement software designing part, object oriented part into the previous video. We have seen the implementation, what exactly the implementation is. We have seen the different coding standards for the methods, for the variables, do's and don'ts, use of the commands, how much importance for following the convention and for following the coding standards, why it is necessary and all that. Yes, so we have done with the implementation part. So today we are moving towards a software testing. So software testing and the testing strategies. Okay, so let's move ahead with the today's topic. Yes, so what exactly the soft so let us first define what exactly the software testing is. Yes, the word defines testing of a software. Like a developer is developing a code, a software developer or a software engineer will develop a code from the software design developed by the designing team, from the use case diagram, from the class diagram. The software developer will convert that diagrams into the exactly executable source. So let's say, uh, as a developer, you are designing a program, to find maximum from the 10 numbers, to find the maximum of a 10 numbers. So what your task will be to write a program in any of the language, C, Java, .NET, any of them, to find any number from the 10 numbers, right? Fine. So uh, it's not only task of a developer to only to develop the code, but do the initial testing whether the code is working properly or not, right? So now this is a kind of initial testing done by the software developer. So while we are dealing with a software consists of so much different components that we have seen in the component level design. That components are interconnected with each other, they are communicating with each other one or more way. So the task of a software developers, there are so many software developers working in a team to create a software, right? So the task of a software developer to create a software for the particular team, for the particular. Now the software, uh, let's say, there are the five components into software, the and there are five developers for developing each of the component. So the whosoever the developer that develop the component for the particular software will do the initial testing on that, right? But to complete a whole software we need to integrate all the components, then who will be like doing all the testing, right? So uh, there should be a team of testers who will do the component level testing as well as the integration level testing. Once all the components are combined, like they have to provide exactly the detailed testing of a software, so that your product should have the minimum bugs, or should your product should be a bug free product, right? So that is a really important thing. So that is nothing but a part of a software testing, and there are the different strategies for doing the software testing. So let's move towards that. So for the introduction, a strategy for a software testing integrates the design of a software test cases into a well-planned series of steps that result in a successful development of the software. So what exactly the software strategy is here? The test cases are created. Now you will be asking what exactly the test case is. Okay, so let's say you are writing uh, a program to find uh, whether the given number is greater than 5, is greater than 5 or not, right? So you have developed the program. Now what will be the test cases for that? Test cases are nothing but all the possible scenario for that particular code of the software, to test whether the code is working for all the possibilities. So how? So to check this particular program, let's say you have developed a program which will check whether your number is greater than 5 or not, whether your number is greater than 5 or not. So what you will do, first of all you will enter the number that is less than 5. Okay, let's 4. You will have some output that is no, this number is not greater than 5. Then you will enter the number 5 that is equal to 5. You will have some answer, and you will enter the number greater than 5. Okay, then you will have the answer. So these are nothing but three test cases. The test case number 1, enter the number less than 5. Test case number 2, enter the number equal to 5. And test case number 3, enter the number greater than 5. So these are the nothing but the test cases of that particular line of code, whether the code is working properly or not, right? The strategy provides a roadmap that describes the steps to be taken when and how much effort, time, and resources will be required. The strategy also, now the what exactly the test strategy consists of? The test strategy consists of to define the test cases. Then the strategy provides a roadmap that describes the steps to be taken if any bug if any bug occurs. Let's say you are testing that particular code which have the which will check whether the number is greater than 5 or not. Let's say if your code is not working fine, then steps should be taken. They should be taken according to the strategy. Like uh, then the strategy incorporates test planning, test case design, test execution, and test result collection and the evaluation. Yes. So to test a particular piece of code, you have to put so many test cases. So the test strategy incorporates test planning, test case design, test execution, and test result collection and the evaluation. The strategy provides guidance for the practitioner and the set of the milestone for the manager, right? This strategy provides like uh, how much like when we'll be completing all the testing, and when the software successful bug free software will be delivered to the user, right? Then the general characteristic of the software testing strategies: to perform the effective testing, a software team should conduct effective formal technical reviews. Testing begins at the component level and work outward toward the integration of the entire computer-based system. So, to perform a proper testing, a whole software team should come together and do the proper technical review of the code. Now what exactly the technical review? Technical review is nothing but let's say any code is written over there. Now it's a time of senior managers or for the tech leaders to come up and review the code, whether the particular developer is writing a code in an efficient manner or not. If he or she is not, then he should be advised that you should write a code in a proper manner. Then testing begins at the component level. The testing, yes, as I told you, testing will be done begin at the component level. Once then all the components are combined, like they are integrated, you have to do the integration testing as well. Different testing techniques are appropriate at the different points in the time. Testing is conducted by the developer of a software and by the independent test group. Yes, this is also the teams. Uh, Testing will be carried out by both. Initial testing of your code will be developed taken by your developer. Obviously, you are writing a code, you will obviously initially test it, but the team of testers have a very much detailed view, like they are like test your code up and down and back and forth. They will do each and every possibility, plus minus zero, everything, right? So this is a task of the testers to find the bug. So the particular software will be tested by both, you can say, the developer of a software team as well as the testers. Testing and the debugging are the different activities, but the debugging must be accommodated in any testing strategies. Yes, we'll come see later what exactly the debugging is, but these are both the different strategies. Now the different terms comes into the picture that is repeatedly asked, verification and the validation, right? Like whether we are doing a testing, whether we are doing the verification or whether we are doing the validation. So let's move towards that. Software testing is a part of a broader group of activities called the verification and validation that are involved in the software quality assurance. Okay, so we are doing both software verification as well as a software validation. So what actually the verification is? The set of activities that ensure that software correctly implements a specific function or a program, right? Okay, so what exactly the verification is? Are the algorithm coded correctly? Then the validation is, does it meet the user requirement? What actually the verification? Let's say you have developed a code. Now you will be checking the algorithm you have write to find whether the number is greater than 5 or not, is working properly or not. So verification deals directly with the coding, while the validation deals with the requirements. Like once you have developed anything, right, now it's time for the validation. Whatsoever you have developed, is it meeting the customer requirement? Is it meeting the customer requirement or not? That is nothing but the validation, right? So in short, we can say a verification is are the algorithm coded correctly? We are dealing on to the code side. Then the validation is, does it meet the user requirements or not? So this is the kind of thing, right? Then we have the organizing for the software or testing. A testing should aim at breaking the software, right? So it's nothing but breaking the software into the piece of components, then doing the component level testing, then the integration there. When done, then do the integration testing, and if any bugs are there, then report the bugs, right? So this is the kind of whole diagram of the software testing, a strategy for the testing conventional software. Yes, this is, we have seen that system engineering, requirements, design and code. After the code, that comes the unit testing, integration testing, validation testing and the system testing. This is the kind of different types of testing we will study today: unit testing, integration testing, validation testing as well as the system testing. Okay, so let's move towards the so levels of the testing for the conventional software. The unit testing concentrates on each component function of a software is implemented in the so it more focuses on the separate component, that is we called as a unit testing. Then we have the integration testing, all the components are combined, then the testing will be carried out. Validation testing against the requirement, like whatsoever you have developed, you have to check with the requirement. Ultimately, if you are developing something that is not stated in the requirement, ultimately you are wasting your time as well as your client's time, right? Then we have the system testing. It's a whole testing. Once the whole software is ready, then this is a kind of, let's say, a whole system testing. System is tested as a whole, right? Then a unit testing exercise. Yes, a unit testing exercises specific paths in the component's control structure to ensure the complete coverage and the maximum error detection. So what exactly the unit testing is? Unit testing is nothing but a kind of testing which directly deals with the code, right? So this is a kind of testing carried out by the developers only, because developers have more deal with knowledge of the code. Testers does not deal with a code. Developers, this kind of testing mostly done by the developer. So they will take care that whatsoever the testing is done, let's say they have written if else while and all the statements. So the unit testing is kind of thing that each and every line should be covered. Each and every line should be covered. So let me give you the example. Let's say we are writing a code. If number greater than 5, okay, then let's say we are printing that is, let's say number is greater 5, that number is greater 5, sorry, here, and we are doing, let's say, else we will write a number less than a number is lesser, just do it greater than or equal to, number is greater or this number or equal to 5, right? So now, so this is a kind of like code you have written, let's say, into the C language, whether it is taking the number is greater than or equal to 5 or not. So the unit testing will check that, will do the type of testing, so that this if statement should be tested, also the else statement should be tested, means each and every line should be tested. So to test that, first of all we have to enter the number 8, okay. So if this line will be tested, then number will be entered, that is a 5. Again this line will be executed. Now I will enter the number 4. Now this line will be tested. So we are doing the maximum coverage, we are doing the maximum path coverage. This is a technical term, right? I hope you are getting my point. This is nothing but the exercise is the specific paths and a components control structure to ensure the complete coverage and maximum error detection. So this is nothing but covering the all the written code. That is nothing but the unit testing. Then we have the integration testing. Integration testing focuses on inputs and the outputs and how well the components work together. So this is a kind of thing, once you have developed all the components, now that all the components will be integrated into the one component, that is nothing but a major component, right? So it focuses on the inputs and the outputs and how well the components fit together and the work together. Validation testing provides a final assurance that the software meets all the functional, behavioral, and the performance requirement. So if you remember, in the requirement analysis, in the requirement engineering, we have covered that. The different type of requirements: functional requirement, non-functional requirement, behavioral requirement into the requirement engineering. So validation testing check all the software features with the requirements, whether they are meeting the requirements or not. While the system testing verifies that all the system elements like software, hardware, people, databases mesh properly, and that overall system function and performance is achieved. Again, the system testing is viewed as a whole. Viewed as a whole, right? Now the testing strategy applied to the object-oriented software must broaden testing to include detection of errors in the analysis and design models. Unit testing loses some of its meaning and integration testing changes significantly. Use the same. So ultimately, this is also applied onto the object-oriented software module. Now the next questions comes into the picture, like when is the testing completed? The answer is there is no definitive answer to this question. We cannot say, even if you notice in today's, still Instagram and the Facebook have the bugs, and the bugs are going to resolve, because ultimately what happens, when you are introducing a new feature, it possible that new feature will affect the old feature, so the bug will come into the picture. So testing is a long term process until the whole product is a bug free. the bigger the system is, the more feature is, the more it's prone to the, so more it will have it probability of the bugs they have. So there is no definitive answer. Every time a user executes the software, the program is being tested. Sadly, the testing usually stops when the project is running out of a time, money, or both. So this is a kind of thing. When the project is stopped, it's not working, then is the we can say the testing is stopped, right? Then one approach is to divide the test results into the various security levels. Yes. Now, ensuring a successful software, the test strategies for the conventional software. So let's move towards one by one towards unit testing. So unit testing focuses testing on the function or the software module. Yes, there are the different components of the software. So it specifically focus on the particular function or a function software module or the particular component. Whatever. Concentrates on the internal processing logic and the data structures. It's simplified when a module is designed with a high cohesion, reduces a number of test cases, allows the error to be more easily predicted and uncovered. Concentrates on the critical modules and those with a high cyclomatic complexity when testing resources are limited. So as I told you, this kind of testing is carried out by developer only. He will test his own logic, own code, own data structures, right? Probability of getting the error. So ultimately, once it's done, the task of the testers will be reduced. This kind of testing will be carried out when the number of testers are less or no testers are there. Right? So it's a small level of small piece of code testing or the module testing, or we can say the small component level testing, right? Then a target for the unit test cases are module interface, ensure that the information flow properly in and out to the module. Yes, it's focuses on to the module, particular module. It focuses on the local data structures, ensures that the data stored temporarily maintain its integrity during all steps of in the algorithm execution. Data stored and retrieved from the data structure follow the integrity, like, right? This you have studied into the database DBMS system. The integrity a plus b equals to should be a plus b onto the both side before the transaction, and the after the transaction value should be same. This is the same case in the case of data structures. Then we have the boundary condition, ensure that the module operates properly at the boundary values established to limit or restrict the processing. This is the kind of thing. Let's say you are writing a program, whether the number is greater than 0 and lesser than 100. So you have to check the boundary values also. Enter the number 0, enter the number 100, enter the number less than 0, enter the number greater than 0. This is the kind of thing, the boundary thing, right? So there should be there to boundary conditions. Independent paths. So this, as I told you, paths should be designed so that each and every line of a code should be covered. In this, paths should be designed so that each and every line of code should be covered. We'll cover more into the detail. So this is nothing but the path defining and the error handling parts. Ensure that the algorithms respond correctly to the specific error condition. So this is a kind of thing the unit testing targets. Now, common computational errors in the execution path: misunderstood or incorrect arithmetic precedence, mixed mode operation, incorrect initialization of the values, precision inaccuracy, and the round of errors. So this is the kind of thing, like as I told you, this is a kind of unit testing is a kind of carried out by developer. It's he or she is testing its own code. So this is a kind of testing which will occur, that is a mixed mode of operation, like data type values, floating point values, and kind of error which will comes into the picture, right? Then we have other errors to uncover, like comparison of the different data types. You are comparing a string with a float, incorrect logical operators. Then we have the incorrect comparison of the variables, improper or non-existing loop, infinite loop you are running, improperly modified loop, boundary value violations, right? So this is a kind of thing that should be checked into the kind of unit testing. As I told you, it's nothing but the checking of your code, and that is mostly carried out by the developer, right? Problems to uncover into the, there is a one term, more term comes into the picture, that is a drivers and stubs. So there is a one kind of drivers and stubs for the unit testing. So what exactly a driver is? A driver is a simple main program that accepts a test case data passes such a data to the component being tested and the prints the returned result. So this is a kind of program which will accept the test data applied to the particular component and give the output. Then what actually the stubs is serve to replace modules that are subordinate to the component to be tested. It uses the module's exit interface, may do minimal data manipulation, provides verification of entry and returns the control to the module undergoing testing. So this is a kind of thing of one function calling the another function. So serve to replace a module that are subordinate to the component to be tested. Then the drivers and stubs both represent the overhead. So this is a kind of, you can say, the utility or the software to do the the unit testing. Then after the unit testing, we have the integration testing. So integration testing, as I told you, software is nothing but a part of a different component. It's a combination of the components. Combining the component makes a whole software. So that is where exactly the integration testing comes into the picture. So integration testing, defined as a systematic technique for constructing the software architecture. Objective is to take the unit tested modules, which are the modules are unit tested, and build a program structure based on the prescribed design. Now there are the two approaches: the non-incremental integration testing and the incremental integration testing. Non-incremental integration testing as well as the incremental integration testing. Now what actually the non-incremental integration testing is, commonly called as a Big Bang approach. All components are combined in advance. The entire program is tested a whole. If any problems results, many seemingly unrelated errors are encountered. Correction is difficult because isolation of the cause is complicated. Once a set of errors are corrected, more errors occur and testing appears to enter an endless loop. So this is a kind of thing in the non-incremental testing, which is that all the components are combined into the advance. Once all the components are ready, just combine into that. Problem in this kind of testing is that there are more number of errors. The finding from where the error is coming is very much difficult. Ultimately we are getting into so much of error. So this is a kind of thing into the non-incremental testing. While in the incremental testing, we are adding the components one by one. So there are the three approaches on that: the top-down integration, the bottom-up integration, and the sandwich integration. So in the incremental testing, we have the top-down integration, bottom-up integration, as well as the sandwich integration. The program is constructed and tested in the small increments. So this is the important. The program is constructed and tested into the small increments. Error are easier to isolate and correct. So this is exactly the feature is, let's say you have tested a one module and added it into the another component. If any problem comes into the one component, you will identify that the error is coming into the particular component, right? Interfaces are more likely to be tested completely, right? So a systematic test approach is applied. So what exactly the top-down integration? The top-down integration modules are integrated by moving the downward through the control hierarchy, beginning with the main module. Subordinate modules are incorporated in either depth first or the breadth first search. Okay, so this is a kind of thing. When you are developing a software, obvious that there will be the main module, then we will have the small sub modules. So in this top-down integration approach, first the main module will be we'll test the main module, then we will get the sub modules. So the sub modules will be get with a different algorithm, either the depth first or the breadth first search, as applied into the data structures, right? So the advantages of this approach verifies major control or decision points early in the test process. If any bugs comes into the main component, no need to test the further component. Disadvantages: stubs need to be created to substitute for the, yes, as we studied into the unit test, stubs is called to the subordinate. So here we are calling the subordinate particular component, so we have to create the stubs. We have to deal with this particular stubs program. Then we have the bottom-up integration. Integration and testing start with the most atomic module. So we are dealing with the small components. Then we are adding the main component, that is nothing but the bottom-up integration. Advantage: this approach verifies low-level data processing. So here we are checking the small modules, then we are going into the modules. So this is more advantages here. Now here we will need a driver module, right? So this is the kind of disadvantage of this. Then we have the sandwich integration. This is nothing but the combination of the both the top down as well as the bottom up integration, occurs both at the highest level modules and also at the lowest level modules, proceeds using the functional group of modules with each group completed before the next, right? So this is nothing, sandwich integration is combination of the both, the top down and the bottom up. Some modules are tested and integrated, some main modules are tested and integrated first, and some lower level modules are tested and integrated first, and this is how the process move on, and finally once all the components are integrated, then the final testing is done. So this was all about the unit testing as well as the integration testing. We are putting this only about this only. We'll see further into the next video lecture. Thank you very much. Have a great day.